Look closely at your wall outlet. Underneath the plastic cover, a silent disaster is already taking place. Your home is consuming its own electrical system, and you probably have no idea it is happening. This is not about bad wiring, it is a modern crisis of dirty electricity. In Charlotte, North Carolina, the Taylor family learned this
David,
truth
look at this.
the
It's
hard
happening
way.
again.
Their modern appliances were slowly destroying the very wires feeding them power. We plug in our phones, laptops, and LED lights, thinking electricity is clean. But modern devices do not draw power smoothly. They chop it up. These switching power supplies draw electricity in high-frequency bursts. This high-speed switching creates massive electromagnetic noise. We call it dirty electricity. For young Leo Taylor, the first clue was a strange, high-pitched hum. He could hear it when the house was completely silent at night. His father, David, assumed it was just a cheap light bulb vibrating. He replaced the bulb, but the hum remained, vibrating through the walls. In a standard home, electricity travels through hot wires and returns through the neutral wire. In split-phase systems, neutral currents from different phases should cancel each other out. But harmonic distortion from electronic loads changes the rules completely. Instead of canceling out, high-frequency currents stack up on the neutral conductor. The neutral wire is not protected by a circuit breaker. It can carry double its rated current capacity without ever tripping a switch. The copper conductor begins to bake inside its plastic sheath. David Taylor noticed the drywall above his electrical panel was warm to the touch. He did not know that a wire behind that drywall was reaching over 200 degrees. We built this channel for people who don't accept that's just how it's done. Join us. Your house is losing value every second this goes unchecked. Subscribe to protect it. Sarah Taylor noticed their television screen flickering whenever the dishwasher ran. An appliance repairman told them the dishwasher was fine. He blamed the house. He was right. The house's electrical network was saturated with high-frequency harmonics. LED drivers are major culprits. They convert standard AC power to low-voltage DC. Cheap LED drivers lack proper electromagnetic interference filters to block high frequencies.
Notice the heavy copper filter
The
coil on this
resulting
premium board.
high-frequency noise feeds
On the
back
cheap
into
board,
your home's
that space
wiring
is left
system.
completely empty.
Standard building wire insulation is made of polyvinyl chloride, or PVC. PVC is a great insulator, but it degrades quickly under constant heat. As plasticizer chemicals evaporate, the insulation becomes brittle and hard. Microscopic cracks allow electricity to leap across conductors, creating arc faults. David Taylor bought a plug-in power quality monitor to investigate their flickering lights. The device immediately began to beep, signaling critical harmonic distortion levels. He called an electrician, but standard troubleshooting found nothing wrong with the voltage.
There is no reason for this to be failing.
Traditional meters measure root mean
120
square
volts,
voltage.
right on the money.
They are blind to high frequencies. To see the noise, you need a specialized high-frequency spectrum analyzer. This noise travels along the copper wire like water through a pipe. But unlike water, electrical noise radiates outwards, creating electromagnetic fields. These fields convert your entire home's electrical grid into a massive antenna. This is electromagnetic interference, or EMI. It disrupts sensitive electronics nearby. Leo's smart tablet began to fail, its touchscreen registering phantom taps. His mother, Sarah, noticed their home internet connection dropping every afternoon. The router was located right next to the kitchen's main electrical conduit feed. High-frequency noise was jumping from the power wires directly into the Ethernet cables. This is capacitive coupling. It bypasses physical insulation barrier systems. The higher the frequency, the easier it is for current to leap. Your home's electrical wiring was never designed to carry these frequencies. It was designed in the mid-20th century for simple 60 Hz sine waves. Back then, loads were linear. Incandescent light bulbs, simple motors, resistive heaters. Linear loads draw current in perfect sync with the voltage waveform. But today, nonlinear electronic loads dominate our electrical system panels. They demand current in short, jagged gulps, distorting the entire grid wave. This is harmonic distortion, measured as total harmonic distortion, or THD. Standard building codes allow up to 5% total harmonic distortion. Have you experienced this in your home? Tell us in the comments section below. This level of distortion turns copper wires into heating elements. The heat is not concentrated in one spot. It spreads throughout the walls. It cooks the insulation of every wire in the same conduit bay. Over time, the wire jackets fuse together, creating short circuits. David Taylor decided to inspect their attic wiring himself. He found their main branch cables running underneath thick layers of fiberglass insulation. The insulation trapped the heat, accelerating the degradation of the plastic jackets. He could smell the faint scent of hot plastic like a warm toaster. This was the smell of PVC slowly baking in their ceiling space. Standard circuit breakers only detect overcurrent and short circuits. They are blind to the slow carbonization of wire insulation. Carbonized plastic becomes a semiconductor, allowing current to flow outside the copper. This creates a high resistance path. It heats up like a stove burner. It does not draw enough current to trip the standard 15-amp breaker. The wire continues to burn quietly inside your wall, undetected. David Taylor called an electrical engineer to perform a complete diagnostic. The engineer connected an oscilloscope to the main neutral bus bar. The screen showed a chaotic mess of high-frequency noise spikes.
Look at these transients!
The neutral wire was carrying 12 amperes of high-frequency harmonic current. This current had no work value. It was pure waste heat. It was vibrating the wire connections inside the junction boxes. This vibration makes screw terminals loose over months of operation. A loose connection creates a high-resistance contact point, raising temperatures. The plastic backing of the outlet starts to char and burn. This is how electrical fires start behind drywall, with no warning. The Taylors had to rewire 3 branch circuits in their home. It cost them over $4,000 to make their home safe. But they also installed a critical device to prevent it from happening again. They installed a whole house electromagnetic interference filter next to their main panel. These filters contain inductors and capacitors designed to shunt high frequencies.
Noise enters the filter. The unwanted interference is blocked, while the clean signal passes through, diverting noise to the ground.
With the filter active, their line noise levels dropped by 90%. Leo's tablet stopped malfunctioning. The high-pitched hum in his bedroom disappeared. But filters are only part of the solution. We must change how we design devices. Modern electronics manufacturers must prioritize power factor correction and line filtering. This reduces the amount of dirty electricity they generate in the first place. You can check your own home for these warning signs today. Listen for buzzing outlets. Feel for warm switch plates. Look for flickering lights. If you find a hot spot, do not ignore it. It is a warning. The electricity in your walls is a powerful force. Keep it contained. Your home is your sanctuary. Do not let its own power destroy it. Take care of your wires, and they will take care of you. Let's dissect the physical anatomy of electrical current degradation inside our living spaces. High-frequency harmonics travel along the outer skin of copper conductors, known as the skin effect. This concentrates the current in a very small area, dramatically increasing resistance. More resistance means more heat, even if the total current remains within safety parameters. David Taylor decided to run a test on their central air conditioning system power lines. The compressor motor was pulling distorted currents, feeding noise back into the main panel board. This feedback loop creates a resonance wave that stresses every connected appliance in the home. Sarah noticed that their digital microwave clock reset itself several times a week. She thought it was a utility grid problem. The reality was much closer to home. The noise was generated inside their own walls by cheap power converters. Every cell phone charger and LED driver was acting like a tiny noise generator. Thousands of these high-frequency pulses occur every second, degrading your wires. This is not a theoretical hazard. It is a documented cause of house fires. David and Sarah decided to consult a specialist in residential electromagnetic mitigation. The specialist recommended installing dedicated line isolation transformers for sensitive gear. Isolation transformers break the physical copper connection, blocking the noise waves. This completely isolates your expensive electronics from the dirty household grid. But the main breaker panel still needed to be addressed. The neutral wires were overcrowded, leading to shared return current stress. Sharing a neutral wire between different branch circuits is a common code violation. It doubles the load on that single copper conductor wire. The Taylor family decided to separate every shared neutral wire in their home.
Sure is, the best conductor.
This required pulling new dedicated neutral return lines through their walls. It was difficult work, but it removed the dangerous return path bottlenecks. They also checked their grounding system electrodes outside the foundation wall. A bad ground path prevents noise from leaving the home electrical system. They cleaned the ground rod connection, restoring the direct path to Earth. This simple fix significantly reduced the high-frequency voltage on their neutral lines. But what about the devices themselves? How do we stop the noise at the source? Premium electronics use active power factor correction, or PFC circuits. PFC circuits force the device to draw current in a clean sine wave pattern. This eliminates harmonic distortion and keeps your household lines clean. When buying appliances, look for the Energy Star and Power Factor ratings. A power factor close to 1.0 means the device is clean. Avoid cheap, unbranded charging bricks and LED light bulbs. They lack the critical safety and filtration components to protect your home grid. By making smart choices, you can protect your home's electrical system. The Taylor family's home is now safe from the electrical diet. Their lights do not flicker, and their wires run cool and quiet. Let's review the copper feeder line connection points in the main service conduit. The ground conductor provides the reference potential for the entire system voltage balance. When the ground path is degraded, noise voltages cannot dissipate into the earth. This leaves the noise trapped in your home's metallic framing and conduits. David Taylor decided to document their home's voltage waveforms before and after. The before waveform looked like a saw blade, ragged and jagged. The after waveform was a clean, smooth circle on the display plot. This confirmed that the electrical noise had been successfully eliminated from the house. Your home's electrical health is the key to preventing modern
Let's set it to the
electronic
perfect
hazards.
eco temperature.
Do not wait for a melted outlet to tell you there is a problem.